Hey, today I want to show you something about a new feature we recently deployed on 9-managed GKE, and it's called application monitoring. It actually does exactly what the name implies, so you can monitor your application with it. What are the features of it? So you can basically, once you implemented it in your application, you can export own metrics into a provided Prometheus instance. You can have alerts and notifications on certain thresholds and conditions. And you can also create dashboards in Grafana based on the metrics Prometheus scraped from your application. How does all of that work? Well, basically we are leveraging the very cool project Prometheus Operator. So to control your metrics or your scraping, you can use the CRDs from them. And what you will get is actually, you can see that here on our 9IT cluster, which I take just as an example. You can see we have an alert manager instance here, and also a Prometheus instance. You can have multiple Prometheus instances, doesn't matter. Those two instances are actually run on 9 nodes, so they will not take any resources of your nodes where your applications will run. And they will also not interfere with your applications. That's how we designed it. But you can still configure all the needed details of those two applications with CRDs, and in case of alert manager, you can actually give the whole configuration via a secret. Yeah, so what did I prepare, or what do I actually want to show? What I want to show is how to configure an already existing application or service to be scraped by Prometheus. So what I prepared for that via GitOps is actually a small demo. Yeah, well, small. You can see that there's actually a lot. The demo consists of a sock shop. That's a demo or microservice demo application from Weaveworks. And additionally, for showing how alerting would work, I also deployed a Mattermost application, which is the open source Slack alternative. Okay, so how do we want to go on? So all of these applications, or all of these pods, you can see here. I will just filter it to only show pods, right? In ArgoCD, all of those pods, at least the non-DB ones, they are actually exporting a metric which will show how long HTTP requests took. Where do I know that, or how do I know that? Well, it's actually documented in the microservices demo, which is the sock shop. They actually say in monitoring, hey, every service will actually have the request duration seconds metric being exposed, where we can also apply histograms on. So, okay, what you will need to actually monitor your application, just showing our documentation here, is a service monitor or a pod monitor. So Prometheus Operator basically here knows two types of monitors, or two types of how to configure your application in Prometheus. A service monitor takes all the pods which are selected by a certain service, a Kubernetes service, into account, and basically creates a Prometheus application, a scrape configuration for them. So Prometheus will then go and ask all the pods behind that service for metrics. That's the resource you will take in 90% of all cases. If your application doesn't have a service, a Kubernetes service, because it just doesn't need it, then there is the pod monitor available, where you select basically pods directly. And yeah, that's just if you don't have a service available. Otherwise, it's the same. And that's what I wanted to show. what we always need to think of in application monitoring is actually we kind of need to connect the service and the pod monitors to our Prometheus instance, and that's what we do with the label. So the label is always 9ch Prometheus, and then here should be the name of your Prometheus instance. So in our case, if I go here, actually, you can see that the instance name is 9IT. That's what I need to use in the label then. Yeah, so let's see here. We actually have services in our microservice or Suckshop demo application. Let's just use cards service, for example, right? Oh, maybe you just want to have a look at the actual Suckshop. So that's a demo, the deployed Suckshop. I already have cards. I have clicked a bit around here, right? So yeah, you have the holy model basically, and yeah, the whole application you can basically buy socks, put them into a cart, proceed to checkout, and yeah, that's it. Oh, where did I click here? Okay, it's a cool demo, by the way. So in the cards service, you can see it here. What you will need are the labels of the service itself, right? So you can see here are the labels. It has a label cards or app cards. It's component cards and component of Suckshop. And those labels we need to use and in the service monitor, because we create a service monitor. What you will also need is the name of the endpoint or the port. So you can see that service actually selects or has a name web, and it takes traffic on port 80 and forwards it to the pod on port 80 as well. So yeah, we actually just need that name. If you have a service without a named port in the service monitor, you can use the target port then. So, okay. So I prepared actually a Git repo already for the demo. It's based or done with customized this time, although I'm more used to Helm. I used customized to just get first a bit more familiar with it, and I also took the manifests from the Suckshop. And I had to change them because the last commit was done, I think, 3 years ago. So I had to adapt some stuff, and that's very easy with Customize because you can just apply patches. So we go to the manifest, Suckshop, right? And I already prepared monitoring directory. What I prepared here is actually the service monitor already. So we have API version and we have a kind service monitor. We have metadata there, especially the label 9ch Prometheus 9IT, as I said before. That's important. That will actually match or assign your service monitor to the relevant Prometheus instance. And here we actually say, or we define the service selector. So I'm just using app card and component of Suckshop. So I'm not using all 3 labels, which I've seen here, or even 4, right? But that one is actually added by ArgoCD. Just using 2, that's enough in that case. And I say, okay, please create the pod on the endpoint or port named web. So that actually already is added to my Git repo. But not to the customization YAML. So customize, edit, add resource manifest Suckshop monitoring, whatever there is a label. Okay, I'm not working with merge requests here. For the demo, I think we can just commit to master. Service monitor for the cards service. Okay, pushing that. Oh, actually, I need to log in. Okay. Okay, so now we pushed it. closed it here. Demo. Okay, we can see that actually already has done the job. It's on the most current commit. But as we are only showing services, we don't see it. But here we have now a service monitor called cards. Yeah. So how to prove that that actually works, so that we're now scraping stuff from the cards service? What we can do is just have a look at our Prometheus instance. And in status, you can actually see the targets. So what will be scraped by Prometheus? Here you can see that we actually predefine stuff. So you will have predefined exporters in your Prometheus instance. So we actually, as you can see here, include Nginx ingress, basically. So you will have Nginx ingress metrics, kubelet metrics from the single kubelets, sorry. So on the CAdvisor endport and also on the normal kubelet metrics endport. So CAdvisor, you will basically get all the container metrics. We also add kubestate metrics and node exporter. And we actually change the metric relabel config in Prometheus. So all the data you will get in your Prometheus will only be from your namespaces and from your nodes in case of node exporter, for example. So we don't pollute the Prometheus instance with data from the 9 nodes or from the 9 applications which we manage. Yeah, so as you can see, nothing happened here. So let's reload. Actually, it always takes a bit of time until Prometheus or Prometheus operator picks up the changes. So we just need to wait a bit more. Yeah, just check service discovery. You can also see basically, yeah, how many active targets we have. Is there anything up now? Oh, it's actually, okay. It picked it up, but the state is unknown because it never scraped it so far. So here you can see demo cards is the actual configuration. And now when I reload, the service is up. So we scrape on endpoint web. The job name is cards, and you can also see the actual pod name of the cards service. So if you would have multiple pods for that single service, you would see multiple endpoints here. Yeah, how to prove? Well, the actual documentation, right, says that there is a request duration seconds metric being exported from the application. So you can go to the graph. And you can see that we actually have them here. So just, I mean, that doesn't make sense now, but executing that. And you can see that the instance for the, where do we have that? There's the exported service cards. Job is cards, and so it actually adds labels, right? So you will have metrics per method, for HTTP method, get, post, patch in that case. I clicked around before, that's why we actually have some metrics here. You can also see that the there's a status code label and also a route label and the pod label on that metric. And that's very cool because you can actually filter by those labels then. So you can have statistics or graphs by method or by status code. Let's just have an example here. So let's say we actually integrate your Prometheus into the predefined Grafana instance. And we can go to the explore mode. Just make sure that the right data sources are selected here. So that's Prometheus 990, that's the right one. So if we say request, right? we actually could say, okay, that's the request duration seconds bucket. That's a very cool feature of Grafana. If you run that, it actually says, hey, time series has buckets, you probably wanted a histogram. So if you click that, it makes just that cool, just makes that cool graph out of it. So what does it say? We are actually checking the 95 percentile of your request, or of the request duration of the card service in a 5-minute window, basically. So what we've seen before, that we have actually those metrics split up on method and status code and all of that. Actually, that's everything now in one metric. So no matter what status code, no matter what route, all the request durations will be summed up here. So if you want to change it, if you want to have more detail, right? You can actually say, okay, I also want to have it by let's say method, right? So now you can see, I will not go to the last hour. I played a bit around before, right? So let's say 30 minutes. That's when we added the service monitor and then when it started to scrape, right? And you can see that post and patch, I recently did not click around in the interface. So that's why we don't have any numbers here, but for GET requests, which is also the health endpoint of the pod itself, we will always have requests. So what does it say now? Well, it actually says that 95% of all requests we get are faster or equal to 0.004 seconds, right? That's what the actual query tells us. So you can even split that further. You can say, okay, I also want to have it method and route. You always actually need to integrate the LE label. That's important for the histogram quantile function. That needs to be existent. So LE always has to be there. And now you can see, okay, health is actually the endpoint which gets constantly request. If we go to our Sux shop here, we say add to cart, and then hot this week. We also want to have this one in the cart, 4 items. Too holy and quite expensive though. But we should now see actually some metrics. We run that. You can already see, okay, for post we get a number, health, and then for get as well. In that case, or in our service monitor, we actually scrape every, I think, 30 seconds, so we should get more. Okay, so now you can see it started. There's just a small point here. If you click on that, you can see, okay, for post and that route, 95% of all requests have been faster than 0.2 4 seconds. You can actually also say, okay, we want to have that automatically reloaded. So that's the way actually to add metrics to your application. You can just define service monitors and pod monitors, and Prometheus will automatically pick that up, create a scrape configuration, and scrape your metrics. If you want to read more about that request duration seconds bucket and the other metrics, if you want to read more about that, I actually recommend the histograms and summaries page on prometheus.io. You can also see the query there for if you want to just have an average query. Basically, you just divide the sum by the count. You can also play with labels there to have more information. There's aptX score, and there's a lot on that page. So that's actually it for now. In the next video, I will show you how to create rules, basically alerting rules, and also the alert manager configuration. Ja, dann see ya.